Okay guys, welcome to another lecture of engineering geology. My name is engineer Abid Ali. Today our topic is about the minerals. What is minerals, why we need to study minerals, and different composition of minerals. Minerals are basically the building blocks of rock, as you guys can see from here. So let's start. Okay, at the end of this lecture you guys would be know about what mineral is, why we need to understand the mineral properties, why it is important for civil engineers, and describing the criteria for classifying minerals, and also to recognize the association of mineral occur. Also the list alternative methods for identifying verified grain material, and set while civil engineers about the clay minerals. Well, this point is kind of important for civil engineers, why we need to know about the clay minerals. Okay. Mineral, this is a short definition about the minerals are naturally occurring inorganic substances which are definite and predictable chemical composition and physical properties which determine its crystalline form or crystal that make up rock. Some exceptions: inorganic solids, sometimes only one mineral in a rock, for example quartz, and not all the minerals are naturally occurring. Okay, why we civil engineers need to study about the mineralogy? Because it influences the strength of rock. Mineral reaction may affect quality of building materials, foundation, permit identification of geotechnical hazard, potential problems, examples. Okay, I would leave this to you guys. You should just mention some example in the comment section and I will go through it. Source of raw material and what are the types. Okay. Pictures guys, as you can see, this is the statue made from stone. So this picture was taken in 1908, and after the several years of acid rain on it, as you can see what the acid rain have done to the stone. Basically the stone is also a mineral, so as you can see the effect of acid rain on the stone. Okay, what is aggregate? Depend on the composition and grain size. Particle needs high UCS and normally range between 5 and 50 mm. Main sources, other sources, I will leave also this to you guys, just let me know about this. Uses road and concrete. Mineralogy vital. Basic mineral good for tar bonding. Granite minerals adhere well to binder in cement. Strength of aggregate must be higher for structural concrete than for ground concrete. Okay, things to avoid: clay and migas. Why we need civil engineers to avoid clays during the construction? Because due to its strength, because these are low in strength and its expansion property is high. Pyrite, weathers to give sulfuric acid and iron oxide, alters to sulfate and expand. Organics, weak and reactive. Salt, corrosion. Efflorescence. What is efflorescence? We will discuss that later. And flint and porphyry, sharp and poor building. Last category give rise to alkali aggregate reaction for fluid plus aggregate from expensive silica gel, causing longer term cracking and corrosion of steel and flaking of concrete. Must be careful with alkali level in recycled aggregates. Okay, this is a picture of coal, which is also a mineral, as it can be called the coal is the king of the minerals. Okay, this is the picture of periodic table of the elements. As you all guys must be familiar with that, there is a huge range of elements in universe. From chemical first principle, we know that the certain elements will not bind with each other, significantly reduce the numbers of elements. I think I don't need to explain this because you guys must be familiar with this in the 9th and 10th grade. Okay, this is a picture of opal, which is also called a mineral, which is composed of hydrated silicon dioxide. Opal is not a true mineral because it is a mixture of quartz molecules and water molecules that form an amorphous solid. It has a vitreous luster and low specific gravity. The sample of Australian opal formed on brown rock and ranges from colorless to translucent white and blue. Note the absence of cleavage. What is cleavage? We guys gonna discuss that in the next slide. So this previous opal from Mexico has fire and has been artificially shaped into a kabucon to be set in the jewelry. Okay, how to control the mineral formation? As the first principle, must be present sufficiently abundant temperature and pressure, must have sufficient time. Only few hundred minerals naturally occur, about 20 to 30 make up the vast bulk of the Earth's surface. This is basically the bar chart of element in the earth crust. As you can see, is the oxygen we have 46.4%, silicon 28.2%, and the aluminium, iron, calcium, sodium, magnesium, potassium, titanium, and in the last we have hydrogen, which we have is 0.14%. Okay, these are basically by weight. Chemical classification of mineral include non-silicate, which is the elements hydroxide, oxide, sulfide, sulfates, halides, carbonates, phosphates. You guys should note that the color is not always a reliable guide to mineral identification. Okay, silicate, commonest group of mineral in crust, basic unit tetrahedron, three-sided. This is basically tetrahedron means three-sided pyramid with silicon in center of 4 oxygen. Other elements bounded between tetrahedron. Relative abundance of silicon relative to other elements change systematically and determine its mineral properties. Okay, this is a picture as we have discussed. It must be like a tetrahedral silicate. So this is, as you can see, we have tetrahedral. This is another picture arrangement of silica. The picture of a mineral. Chemical composition is not enough. So as like polymorphs, they are basically same in chemical composition but different mineral structures and also different crystals. How to identify minerals? Minerals have crystalline form. What is crystal? A solid of regular shape and for a given compound characteristics angle form when an element or combined solidifies slowly enough as a result either of freezing from the liquid form or precipitating out of solution to allow the individual molecules to take up regular position with respect to one another. This is basically an example of crystals like the hotel where all the rooms are same and repeating. As we discussed from the definition, this is the shape of the crystals. Okay, this is the shape of the crystals as we have discussed in the previous definition. Crystal form cleavage. This is basically a useful indicator of crystal structures. Minerals grow breaking along particular planes. Note number of planes and angle, often useful information about the crystalline structure. These are basically different types of crystal forms, like the hexagonal pyramid, hexagonal prism, prism blade, octahedron, needles, cube. Okay, this is another. You guys just go through it. If you guys have any questions, feel free to ask in the comment section. Okay, 4 different rocks or aggregates of mineral crystals. Number 1 is the rock composed of numerous mineral crystals of amethyst, a purple variety of quartz. 2 crystals have been outlined to emphasize their crystal form and dots show the boundaries between their crystal faces. Number 2, an aggregate of intergrown calcite mineral crystals. The calcite crystals grew together so their crystal form is not visible. Number 3, an aggregate of brown potassium feldspar crystal, white plagioclase feldspar crystal, grey quartz crystals, and black biotite crystals. Like the second, the crystals grew together so closely that the crystal form is obscured. And number 4th one, a variety of quartz called agate. It is composed of a variety color quartz crystals that are cryptocrystalline, which are basically not visible in the hand sample in most of the bands and layers. Okay, as the dotted line, as you can see, the outline is the crystal faces. This one is the crystal faces and this one the crystal outline. This is another example. Okay, and that would be all for lecture number 2. If you guys have any questions, feel free to ask in the comment section. Thank you so much.